Hi everyone, so we're going to do model problems 1, 2, and 3 on this video. And I already did model problem 1 on the other video, but I figured let me just redo it. Alright, so the formula is S equals theta over 360. Theta has to be your central angle, so it's the piece of the full circle. The full circle is 360, and I just want a small angle of it. Then the next part of the formula is the circumference, because we want a piece of the circumference. So it's 2 pi r, which is the formula we already know. So theta comes from your central angle, so we're going to plug in 60 over 360, 2 pi, and we're going to plug in 5 for the radius. Okay, once you do all that, you can plug in 60 times 2 times 5 divided by 360 in the calculator. You will get 600 pi over 360, and that would reduce to 5/3 pi. Okay, next question, model problem 2. We also want the arc length here, but the problem is it's in radian mode. We have to get it in degree mode first. So let's do that first. So we're going to do pi over 6. We're going to multiply it like we did yesterday over 180 over pi. The pi's cancel, and 180 divided by 6 is 30 degrees. Now we know this angle is 30 degrees, and we could go forward with our formula. The formula again is the angle over the full circle 360, circumference 2 pi r is 18. Plug it all in the calculator. Usually they want it in terms of pi if they don't specify. Okay, so do not put pi in the calculator. Everything except pi, and you should get a 3. So your answer is 3 pi in this case. Now, they're both centimeters, so they're actually centimeters. Okay? And of course, you could get a decimal if they asked you for the nearest tenth. You would do 3 times pi and get a decimal. All right, in model problem 3, it's a little different. So of course, it has to be the central angle, right? So they gave us that the central angle is 2.5 radians. So we do have to change it 2 degrees first. And they give us the arc length. So we're kind of working backwards on this one. So if they give us the arc length is 20, we have to figure out the radius. So that's going to be the variable we're solving for. So let's put all this here. We're going to use this formula. We have S is 20. So for S, we're plugging in 20. Theta, we're going to figure out in a second. It's 2.5 radians, but we have to change radians into degrees by multiplying by 180 over pi. And then we're also going to just put in the rest of the formula, and we're looking for the variable r. Okay, so first we want to change this into degrees. If you put all this into the calculator, you will get 143.24 degrees. So that is now this angle. And hi, baby, you want to say hi? What's the matter? That is Analia. She wants to make an appearance in the video. Yeah, you're so silly. Okay, so we're going to plug in the degrees. If you do this part of the formula and you get just a number, I'm going to bring down the 20. I'm going to bring down the r. The number over here is going to be 2.5 if you did all this part in the calculator. Now just solve it like a regular variable. All right, Analia. R is 8. So that is your radius. And you could always check by plugging it back in. So you could check if you get S, which is 20. What do you want to tell them? Okay, so if you did all that in the calculator, you should get as a check. Okay, so if you need more help, you can reach out to me, or you can rewind the video and re-go over these. All right, so good luck, and try to do those problems below.